Hello, fifth grade math students. This is Mrs. Gravenese, and welcome to your very first virtual learning day in math class. So a couple of guidelines for when you are doing your virtual learning lessons. Be ready to learn. That means find a quiet place to work. Have out a pencil and your math notebook or something you can now designate as your math notebook. And then as the lesson is progressing or when you're finished, you can message your teacher if you need help. And you can do that on Google Classroom. You can send a message there or ask your parent to message the teacher through talking points. So those are good methods. All right, let's do a warm-up. So our first warm-up says to write each fraction in simplest form. There are 6 problems. Go ahead and pause the video, and when you're finished your 6 problems, then you can unpause it, and we're going to go over the answers. Hit pause now. Okay, so let's go over your answers. The first fraction says 8/24. So we need to take 8/24 and write it in simplest form. To write a fraction in simplest form, in case you have forgotten, what you need to do is divide the numerator and denominator by the greatest common factor of those numbers, or any common factor of those numbers. It just might take a few extra steps. So what I'm thinking of are, what times tables give me an 8 and a 24? Well, I know I can divide them both by 2. I can divide 8 and 24 both by 4, but I can also divide 8 and 24 by 8. 8 is the greatest of the times tables where I can find an 8 and a 24. So if I divide them both, that's an ugly 8. If I divide them both, oh boy, by 8, that's the GCF, and that will give me simplest form. 8 divided by 8 is 1. And 24 divided by 8 is 3. So the simplest form of 8/24 is a third. That means that 8/24 is equivalent or equal to a third. It's just reduced into its simplest form, or the smallest number of pieces that it is divided by. All right, let's do the second problem. Sorry, my computer's a little slow. So we have 6/9. So we need to take 6/9 and write it in simplest form. So you should be thinking of which times tables have a 6 and a 9. And in this case, other than 1, the only times table that has a 6 and a 9 would be your 3 times tables. So that means that my GCF of 6 and 9 is 3. And I can divide 6 and 9 both by 3. 6 divided by 3 is 2. 9 divided by 3 is 3. 6/9 simplified gives you 2/3. The next one is 4/12. So let's take 4/12 and think of the times table we find 4 and 12. So I can divide them both by 2, but I can also divide them by 4. So I pick the bigger number, which is my GCF. 4 divided by 4 is 1, and 12 divided by 4 is 3. So 4/12 is equal to 1/3. That means that 8/24 was a third, and 4/12 is equal to a third. So that actually means that 8/24 and 4/12 are equivalent fractions. Let's look at the remaining 3 problems. 5/10 is equal to 1/2. I can divide by 5. Five is the GCF, and I get 1/2. Sorry, it's sloppy. 14/35. I can divide both of those fractions by 7. 14 divided by 7 gives me 2, and 35 divided by 7 is 5. So 14 35ths reduces down to 2/5. And how about 9 and 36? I can divide 9 and 36 both by 9. 9 divided by 9 is 1. 36 divided by 9 is 4. So 9/36 reduces down to 1/4. That should be a review from earlier this year, and maybe even from last year as well. So now let's get into our lesson. Our first objective today is that I will be able to multiply whole numbers and fractions. Here's just a quick guide on our lesson today. So multiplying whole numbers and fractions, first off, if you're multiplying a whole number, you have to turn it into a fraction. And we can write whole numbers as fractions by writing a denominator of 1. For example, the whole number 2 is the same thing as 2 over 1. Because 2 over 1 is 2 divided by 1, and 2 divided by 1 is 2. How about if we're multiplying fractions and whole numbers? So to multiply fractions, you multiply your numerators, and then you multiply your denominators. So if our example is 2 times 2/5, first thing, we would take that 2 and make it a fraction by putting a 1 as the denominator, and then we multiply across. 2 times 2 is 4, 1 times 5 is 5. Let's take a look at some more examples. If you happen to have your My Math book at home, then you should definitely have it out. We're on page 725, but for most of you, your books are at school. So just follow along. You can write these problems down if you would like. But most importantly, just follow along in the beginning. So you can write a whole number as a fraction. I showed you this earlier. So we have our 12 is the same as 12 over 1. Example 1. Wild parrots spend 1/6 of the day looking for food. How many hours a day does a parrot spend looking for food? You need to know something. You need to know that in a day, there are 24 hours. So there's actually a small conversion that we have to do in this problem. You had to convert a day into hours. So that's how we get the 1/6 times 24. When you're taking a part of an amount, for example, if you're taking 1/6 of 24 hours, in that case, we're multiplying. Of means multiply when you're taking a part of a number. Just keep that in mind as we work through some word problems. So to multiply a 6 times 24, we make 24 a whole number by putting a 1 as the denominator, and then we multiply our numerators. 1 times 24 is 24, and then we multiply the denominators. 6 times 1 is 6. Now that's an improper fraction, which is kind of ugly. So I'm going to divide it out. Remember, fractions are division. So 24 divided by 6 is 4. So a wild parrot spends 4 hours a day looking for food. 1/6 of 24 is 4. So here's our check. 1/6 times 24 is 1 times 24 divided by 6, which is 4. Here's your key concept. When you multiply a whole number by a fraction, write the whole number as a fraction. Add 1 to that denominator. Then multiply the numerators and then multiply the denominators. Let's do another example. Find the unknown in 2 times 4/5. Remember how I told you that when you take a part of a number, you can say the word of? So this is the same thing if we think of the commutative property and flipping those numbers around. This is the same thing as saying 4/5 times 2, which is really 4/5 of 2. So we're taking a part of 2. We can estimate by keeping the 2 a 2 and saying 4/5 is close to a whole. So our estimate could be 2. All right, our first step is write 2 as a fraction. So we take the 2 and we put a 1 as the denominator. Then we multiply our numerators. 2 times 4 is, 8. And then we multiply our denominators. 1 times 5 is 5. And that's improper, so we simplify. I know this can be tricky for a lot of people. Think of this as 8 divided by 5. So you could set it up as a long division problem. How many 5s come out of 8? 1. 1 times 5 is 5. Subtract. You have 3 left over. Now we're not writing a remainder because we want this as a fraction. So we take our remainder, goes up here as our numerator, and then we take our divisor, the number of equal groups, and that becomes our denominator. So 8/5 is the same as 1 whole and 3/5 left over. Okay? So just to recap for this problem, 2 times 4/5 equals 8/5, which is the same thing as 1 whole and 3/5 left over. So we can check to see if it's close to our estimate, which was 2. Now this is a little off right here. I don't know why, but 1 and 3/5 is close to 2, so we know our answer is correct. Here's the guided practice. I want you to pause this real quick, give it a try in your notebook, and then I'll go over it with you. Hit the pause button. Okay, let's go over your answer. Find 1/2 times 4 and write in simplest form. Yes, always, always, always in simplest form. Unless you're told not to, you need to write all answers, all fractions in simplest form. Don't make Mrs. DeMarco yell at you about that. So 1/2 times 4 is the same as saying 1/2 of 4. And you might be able to do that mentally. What's half of 4? Think about it. If we wanted to practice the procedure, we make 4 a whole number by placing a 1 underneath as the denominator, and then we multiply across. 1 times 4 is 4. Multiply your denominators. 2 times 1 is 2. Remember, fractions are division. So 4 over 2 is 4 divided by 2, which is 2. So half of 4, or half times 4, is 2. All right, I'm going to jump into the next lesson, actually, because, oh, my computer's slowing down a little. There we go. Oh. Well, eventually, there it is. I'm going to jump to the next lesson because it's very similar. So lesson 10.6 is multiplying fractions. And as you see, it's pretty much the same thing that we just did. So when we multiply fractions, it's similar to multiplying a whole number and a fraction. To multiply fractions, you multiply the numerators, and then you multiply the denominators. The only difference here is that we don't have any whole numbers, so we're not adding 1 as a denominator. There are 2 methods on how to do this. I'm going to show you both ways. You can practice whichever method you like better, and then I'll tell you when to use these. Franco ate some pizza. 2/3 of a pizza is left. Deandra ate 3/4 of the leftover pizza. How much of a whole pizza did Deandra eat? So, first off, I notice 2/3 is written in word form. That might confuse some people, so you might want to write it as a fraction, 2/3. So there's 2/3 of a pizza, and Deandra ate 3/4 of that pizza. So she ate part of 2/3. See how we have that word of again? We're taking a part of something. So that indicates that when we take a part of an amount, we multiply it. So one way to do this is the way that we just did in the other lesson. Multiply your numerators. 3 times 2 is 6. Multiply your denominators. 4 times 3 is 12. Of course, simplify. I can divide 6 and 12 by 6, leaving me with 1/2. So Deandra ate half of the whole entire pizza. She must be hungry. Maybe she's in social distancing and she's raiding her fridge and freezer and pantry like everyone else. All right, another way to attack this problem from the beginning is simplifying your problem. So in the first way, we simplified our answer. So we multiplied, we got an answer, and then we simplified it. Another way is to look at your problem and simplify your problem. Now I'm going to redo it down here just because I like to go through step by step. So if you have 3/4 times 2/3. When I look at my multiplication problem, I notice if I check my diagonals, I'm looking to simplify the diagonals. The first thing that jumps out at me is diagonally, I have the same number here. I have 3 and 3. That's like dividing 3 by 3. I can reduce them and turn them both into 1. I'm essentially taking 3 and saying, okay, if I have 2 3s, what can I divide them both by? Well, I can divide them both by 3, which gives me 1. And then I can look to my other diagonal, 2 and 4. What can I divide 2 and 4 by? 2. So let's change them. What's 2 divided by 2? 1. What's 4 divided by 2? 2. So I've rewritten the problem. I now have 1 over 2 times 1 over 1. Well, 1 over 1 is a whole, and a half times a whole is still a half. So I still get that 1/2 that I got the other way, but I simplified my problem, not my answer. This is a really useful tool in a few cases. Number one, if you check your diagonals and you have the same number in your diagonal, that's easy. They both turn into a 1. But also, if you have larger numbers as your numerators or denominators, and multiplying across would start to get kind of complicated, and then maybe simplifying would be complicated, I would check to see if you can simplify your problem. Okay, now this one wasn't too complicated, so maybe you chose this first method, and that's perfectly fine. All right, let's look at another example. Modeling with multiplication. What we need to know is that to find the area of a rectangle, you multiply length and width. That's something that you should have learned in 4th grade. So it says find the area of the rectangle with a length of 3/4 of an inch and a width of 5/9 of an inch. So one way to do this is to tile the rectangle as a part of a unit square. So if I take my first fraction, 3/4, and as you can see going across, I have 1, 2, 3, 4 total, which represents the denominator 4. And then I need to shade in 3 of them. So 1, 2, 3 of the 4. Okay. Now I'm looking at 5/9. I have 9 total going vertically up and down, and I need to shade in 5 of them. So 5 of them get shaded. And I always start at this bottom left corner. 1, 2, 3, 4, 5. And then the 5 by 3, I make into a rectangle, into an array. And that actually gives me the fractional amount out of this total. So what I've done is I can count 5 times 3 is 15 out of, well, I had 4 by 9, which is a total of 36. So how many are shaded? 15 out of 36. You can see that right here. Could I simplify 15/36? Yes, I can. I can divide them both by 3. 15 divided by 3 is 5. 36 divided by 3 gives me 12. 5/12 is my fraction. This method of using an area model may or may not be useful, or you could just multiply, okay? Multiplying fractions is actually easier than adding and subtracting because you just multiply. 3 times 5 is 15. 4 times 9 is 36. You could simplify it, okay, and we still get 5/12. So the area of the rectangle is 5/12 of a square inch. And lastly, guided practice. Pause your video, take a minute and work on this problem. Okay, so let's find 1/7 times a half and writing it in simplest form as usual. Multiplying your numerators. 1 times 1 is 1. Multiplying your denominators. 7 times 2 is 14. Guess what? That's already in simplest form. When 1 is your numerator, you know you have it in simplest form. Just as easy as that. 2 multiplication problems. All right, you will be assigned some stuff in Google. Okay, I'm just looking at the independent practice. Real quick, I do want to show you another simplifying the problem. So if I look here at number 10, when I check my diagonals, I notice I have 2 5s diagonally. And think about it, what do they turn into? 1s. So instead of going 3 times 5 is 15, 5 times 7 is 35, let me simplify it. I can now say 3 times 1 is 3. 1 times 7 is 7. Boom! I am done that problem because I simplified my problem. Okay? All right, so you're going to get an assignment on Google Classroom. Go ahead and work on that assignment at your leisure. I'm going to say goodbye for now, and I will see you again with another lesson. Message your teacher if you have questions. Bye now.